Welcome. This is Wilson. I have two life updates. I deleted Pokemon Fire Red, which I think was great. I'm glad I did it. So today I had no option to. Today I went straight back into coding. I did not waste time playing video games because if I had done that, it would have been horrible. So that's number one, and I already feel that today has been more productive than the past couple of days because I wasn't playing that video game anymore. I was almost towards the end, like I had defeated after the like I didn't record it, but I had defeated the seventh gym leader as well, who is Blaine. People who know about Pokemon would know what collecting badges means, who Blaine is. But for people who don't know, you have to collect 8 badges in Pokemon and then challenge the league. And I had to collect just one more badge, and then the game was pretty much the main story was over. And I was thinking that Pokemon Fire Red does not have that much. It doesn't have an interesting plot like Pokemon Emerald. You went to the Sevi Islands and saved that little girl from Hypno, but I don't know if that plot was in Pokemon Red because I never played Pokemon Red. But there's a lot more battling in Pokemon Fire Red. But anyway, I'm glad I deleted that video game. And a good thing about using Linux is that it's very difficult to download games on it. So that means you end up not playing video games, because when I had Windows on this laptop, Windows operating system, I had Minecraft on it as well. So if it wasn't for that game, then I'd be playing Minecraft and I'd be recording Minecraft videos all day long and be playing it all day long. I don't know if I will get back to it. I don't think it's worth it. Like today, already I feel more productive. So that's point one. I think this is buy for video games for now, because video games just are addictive. They're a distraction. At the end of the day, I think my video game, Pokemon videos, were not getting that many views anyway. 1:1. The videos are more, the views are more, but that's maybe also because there's just so much more content about those video games than about coding. So that's life update 1. Life update 2 is that I was doing Vue today. Now I have to incorporate Vue, and I was the app is supposed to be a Maven app, so Mongo, Express, Vue, and Node.js, and I've only been using Express and Node, the JavaScript part. I've been using just vanilla HTML, CSS, JavaScript to create this app, and I've been so reluctant to use Vue. It's just such a painful process to use Vue. But now I've realized that I should incorporate it now, because then it'll be easier. It'll be much harder to then change the whole code as the code base gets more and more complex. And I was going through the Vue docs today, and there's a hands-on approach to this. And so today I've learned a big lesson, and this lesson is that you have to constantly keep on studying as well, because if you don't, then your knowledge base would stagnate. And so if I had studied Vue, studying in computer science is not like studying in biology or neuroscience, which I'm familiar with, which is memorizing facts. This is more like a hands-on thing, and you have to. And really, there's not that much difference. You have a bunch of more keywords, but really, and then there's difference in file structure and stuff like that. But there isn't that much of a difference. So with your actual coding job, you have to also keep on studying in order to improve your skills. And I don't know where marketing and sales fits in this, because that is also important if you want to grow your company. and managing the team and meetings. And but as far as like the programming job is concerned, two things are very important: the actual programming, that you're sitting down and writing code, and studying. So yeah. Yesterday we left off here, and I think this was like the y-axis in programming is top to bottom, y-axis in math is from left to right. So we continue on to the next section, inputs and outputs. I'm recording from the same cafe near my library. It was very quiet now, but I think some people have walked in. So the programs you have written so far are pretty boring. You write down an expression or several expressions and you click run. You see some results. If you click run again, you see the exact same results. As a matter of fact, you can run as often as you want and the same results would show up. Of course, the code is the same. In short, your programs really are like calculations or on a pocket calculator, except Dr. Racket calculates with all kinds of data, not just numbers. That's good news and bad news. It's good news because programming and computing ought to be natural generalizations of using a calculator. It's bad because the purpose of programming is to deal with lots of data and get lots of different results with more or less the same calculations. I think it's saying it should be dynamic. I'm using Vue's terminology like dynamic rendering. So let's say the results have to be dynamic. It should also compute these results quickly, at least faster than we can. You need to learn more still before you know how to program. No need to worry though. With all your knowledge about arithmetic numbers, strings, Boolean values, and images, you're almost ready to write program that creates movies. Okay, so we'd be creating films, horror films, maybe. Not just, or those kind of films. Not just some silly program for displaying Hello World somewhere. And that's what we are going to do next. Just in case you didn't know, a movie is a sequence of images that are rapidly displayed in order. If your algebra teacher had known about the arithmetic of images that you saw in the preceding section, you could have produced movie in algebra instead of boring number sequences. Well, here is one more such table. So basically, this is like they are trying to produce a movie. So one, and then this is basically a function. 2 into 2 is 4, 3 into 2 is 3 into 3 is 9, 4 is 16. It's like this is like x and this is x squared. Your teacher would fill in the blank and replace, and then this would be 100. It turns out making a movie is no more complicated than completing a table of numbers like that. Indeed, about such tables. This is probably shifting it along the y-axis, and this is going to be concrete. Your teacher should ask you to draw the fourth image, the fifth, because a lot of images are some 20, 30 of them per second. So you need some 1/200 to 1/800 of them to make 1 minute's worth it. You may recall that your teacher not only asked for the fourth or fifth number in some sequence, but also for an expression that determines any element of the sequence from given x. In numeric example, the teacher wants to see something like this. Y is equals to x into x. So that's what I said, it was x squared. If you plug 1, 2, 3 and so on for x, you get 1, 4, 9 and so on for y. Just as the table says, for sequence of images you could say something like y is the image that contains a dot x square pixel below the top. The key is these one-liners are not just expressions but functions. See, this is what I was saying, so that was just x squared. This is very basic algebra, but here's one thing I want to share as well, and this is an interesting anecdote, and you might like it. You know, when I was a young child, when we were doing math, it was just memorizing math, and I didn't realize what math was doing. And I thought math and science were separate. It's actually not true. Let's say in physics, they use these equations to solve problems in physics, and math is used to answer, like to predict things basically. But I thought science was all about experiments and math was all about like calculations. It's not correct. In physics, they use math to predict things. I mean, this might not come as a surprise to many. People would say, "Oh yeah, you use math to predict science." But in biology, we did not. Like my whole degree, we didn't. We used a lot of statistics, and one can argue statistics is probably science and math is just different. But you use a lot of math in science as well, and especially in physics. So, and if I had known that, then I'd be like, oh yeah, math is great. Just like this example when they were saying that yeah, movie is just about algebra, and it's true. And in video game, when you're designing video games, you use this kind of algebra. It's linear algebra, but still. And this is why like school sucks so much, because like you don't learn anything in school. Like literally everything is just crap. Everything just sucks. But even the universities are now like really crappy. But if it wasn't for like, but I still think my undergrad was good because my master's was completely crap. Like that whole degree was useless as fuck. Pardon my language, useless as shit. But like the undergrad part, I learned to think about things more, and you took things at face value. And now when I thought about these equations, and now it starts to make a lot of sense. Oh yeah, why do we use these equations? Because it helps you predict things, like that movie example. So sorry, I apologize for my language. And if you want a life lesson from this, I would very strongly recommend not to do a biology degree in undergrad. Do a degree in computer science, physics, math, or engineering. And even if you want to be a doctor or lawyer after that, if you do a degree in like computer science or math, you'll still have like a job. So don't be me. Don't do a biology related degree, and don't do neuroscience. Neuroscience is crap. So at first glance, functions are like expressions, always with a y on the left, followed by a sign and an expression. So this is an expression. They aren't expressions, however. And the notion you often see in school for functions is utterly misleading. See, this guy also hates school. Why do we even have fucking schools? I don't really. Sorry, I apologize for my language again. Why do we have schools? I don't really understand. Like, we don't learn anything in schools. In Dr. Racket, you therefore write functions a bit differently. Define y, x. So, basically, when you have an input, like, I'll just make things a little bit simpler. Because this is something I understand. When I make, I'll refine this series on like Daily Dr. Racket, and I'll make them more scripted, because this is also my like second time reading this book and I didn't finish it. But so now when you have a value like this, x2, you try to run it. I don't know if I'm getting it right. Yeah, let's see, but basically we're trying to define a function y, which takes the value of 2. I'd have to delete this, sorry. Yeah, so you get 4. So we define a function y, which takes an input x, and then this is the computation you perform. But this is a simpler way. I'll read this to you. The define says consider a function y. So consider this function y here, which like an expression computes a value. Okay, x computes a value. A function though depends on the value of something called the input, which we express with the yx. Since we don't know what the input is, we use a name to represent the input. Following the mathematical tradition, we use x here to stand in for the unknown input, but pretty soon we can use all kinds of names. Yeah, you can use square, circle. You can replace this x basically with anything you want to. The second part means you must supply one number for x to determine a specific value for y. So here you have to plug in one number like I did here. So basically you are saying in this x you have to plug something in. When you do, Dr. Racket plugs the value of x into the expression associated with function. So in this value gets plugged into this expression, which is associated with this function. Here the expression is x into x. I always got confused with what expression is, but basically anything that, oh man, I pressed Ctrl plus R instead of Ctrl plus H. Once x is replaced with the value, say 1, Dr. Racket can compute the result of expression, which is also called the output of the function. Mathematics also calls y1 a function application, but the teacher forget to tell. But yeah, this guy is taking a lot of digs on the math course as well. I must tell you that at university, these guys hate teaching, like your research professors. They absolutely detest teaching, and the ones that do like teaching are usually not very good at research. I mean, this might not be causal, but like a lot of like good scientists, they hate research, they hate mentoring people, they hate training people, and obviously because their main interest, like teaching is a job for them, but their main interest is research and publishing papers. Now some might even not want to like publish papers and write grants, and their passion may just be research, but you know, academia is bad, like really bad. Now click run and watch nothing happens. I've already tried with y as 2, but let's try y as 1. And what do we get here? 1. Nothing happens. Nothing changes. If you hadn't accomplished anything, but you did, you actually defined a function and informed. As a matter of fact, the latter is now ready to use as a function. At the prompt in the interaction area, you watch 1 appears in response. The y1 is a function application in Dr. Racket. And try y2, you see pop 4 pop out. Of course, you enter all these expressions. So basically, it's squaring everything. So that goes 3, that goes 4, there goes 5, and you R. And so now you have this 1496, which are the numbers from the table. Now determine the missing entry. Is there a missing entry here? I don't think so. I mean, you can have a 6, basically y is 6, if that's what it means. Yeah, probably that's what it means, y is 6. Oh no, this one. This is what it means, y10. But I already knew it was 100, so. y10, see, it's 100. So yeah, hooray, we calculated y square, but I already knew what it meant. So maybe some people might find it useful. What all this means for you is that functions provide a rather economic way of computing lots of interesting values in a single expression. Indeed, programs are functions. And in, I don't know like if you're interested in math or something, but there's like a very popular math professor, and he wrote this book, All the Math You Missed in High School or All the Math You Missed in College but You Need for Graduate School. And in his lecture he said that functions define the world. So he says everything is a function, and so that's basically true of the world as well. So this is the thing, computer science is true on a fundamental level as well. And once you understand functions well, you know almost everything there is to know about programming. See? I already know. Given their importance, let's recap what we know about functions so far. First, define function name, input name, and this is the body expression, is a function definition. Okay, so you might want to highlight this. You recognize it as such because it starts with a defined keyword. It essentially consists of three pieces, two names and an expression. Okay. The first name is the name of the function. You need to apply the function as often as you wish. The second name is called a parameter. This is a parameter. This is not an argument. Like this, people get confused with this a lot. This is a parameter and not an argument. This is an argument, the actual value that you pass. The first is a function in the function. The second is called a parameter, represents the input of the function, which is known until you apply the function. The expression dubbed body computes the output of the function for a specific input. So this body would compute the output, so like the x into x squared in our example. Second, function name argument expression is a function application. So once you define the function, you apply the function. The first part tells you the function you wish to use. Okay. The second part is the input to which you want to apply the function. If you were reading a Windows or a Mac manual, it might tell you that the expression launches the application called function name, and that it is going to process argument expression as the input. Like all expressions, the latter is possibly a plain piece of data or deeply nested expression. I didn't even know what it said, but let's just delve. The second part of the tell you apply input to which, so basically an argument. If you were reading a Windows or a Mac manual, it might tell you that this expression launches the application called function name and the going to process argument expression as the input. Like all expressions, the latter is possibly a plain piece of data. So basically, when you start something like this program, I think it's probably saying the on click. Here you use JavaScript, and it's like the on click is like the argument. Okay. So yeah, like this expression launches the application. So if you press like F4, then that is an argument as well. Function, I don't know if I'm being precise, but I just read through it. I think that what you need to know is that you have the function name here and you have the argument expression. This is which launches the function. This gets computed by the body. Okay, functions can input more than numbers, and they can output all kinds of data too. Our next task is to create a function that stimulates the second table, the one with images of a colored dot. Just like the first function simulated the numeric table, since the creation of images from expression isn't something you know from high school, let's start simply. Do you remember empty scene? We quickly mentioned it at the end of the previous section when you type it into the interaction area. So now you have to, basically you have to create images. Do you remember the empty scene? So Dr. Racket produces, you can add images. I think the 160 is, I just want to see where it ends. So, because I'm thinking of ending it soon. Because this would get very long. We might continue tomorrow. So we'll start drawing pictures tomorrow. So yeah, that's it for now. Like and subscribe. Stay tuned for more. Consider donating through PayPal, and peace out.